We're going to start into the next section of this unit, which happens to be on volume and surface area. Today's video will focus on volume. Some people like to think of volume as filling formulas. So if I were to fill this shape or fill this shape here, what would it hold or how much space would it occupy? Surface area, they often refer to them as wrapping formulas. So if I wanted to wrap this as a gift, all right, how much wrapping paper would I need? And each shape has its own formula. Okay, there are general formulas for prisms, but when we get into these other shapes, we'll have a particular formula or a specific formula. First thing we need to know are the names of these shapes. Walker told us this one on his way out. What is it? It's a cube. Okay, it's a cube if all the dimensions are the same, if the length, width, and height are all the same. And that's what I tried to do here by indicating that the height is x, the width and length are both x as well. Anyone know what you call this one? Rectangular prism. Nice. So it'd be great if you could write these down. In this case, the length, width, and height are all different dimensions. What do you call this one? A ball. It's a sphere. What do you call this one? Looks like a can of soup. It's a cylinder. This is a rectangular prism because the base is a rectangle. This one is a triangular prism because the base is a triangle. Now, you wouldn't call this one a circular prism, even though that's technically what it is. There's a special name for that called a cylinder. Number 6, it's a party hat. The cone, that's right. And there's special formulas for these ones that come to a point. Last one, anyone know what it is? It's a pyramid, that's right. And you could have triangular pyramids if the base is a triangle, or a rectangular pyramid if the base is a rectangle. Next slide shows some particular formulas for each of the shapes. And it talks about area. Okay, I'll blow by this one because we're going to look at volumes. All right, these are the formulas we are going to look at today. You can't find the volume of a two-dimensional figure. Volume, the shape has to be 3 dimensions. Okay, so for the volume of the cylinder, you could use this formula, pi r squared times h. For the volume of a sphere, it's 4 times pi times r cubed divided by 3, or 4/3 pi r cubed. For the volume of a cone, it's pi r squared times h divided by 3. For the volume of a pyramid, it's length times width times height divided by 3. And for the rectangular prism, length times width times height. In general, okay, you all have this sheet in front of you. Look at the bottom. This is a great way to figure out the volume of a prism. All you really need to do is figure out the area of the base. So the area of the base will depend on what the shape of the base is. If it's a rectangle, the area of the base would be the length times width. If the base is a triangle, it would be base times height divided by 2. If the base is a circle, what's the area of a circle? Anyone know how to find the area of a circle? Pi times the radius squared, pi r squared. That's where this comes from. Look. If I go back here, the area of a cylinder, pi r squared, because the base is a circle, times the height. For the rectangular prism, it's the length times width. That would be the area of the base, that part right there, multiplied by the height. Okay? The ones that come to a point, here's a little trick. If it comes to a point like a cone or a pyramid, you have to divide it by 3. So you can still work area of the base times the height, but divided by 3. Here are 3 examples to look at. Okay? So let's focus on that area of the base times the height. And you have these in your notes. I understand it's hard to see. But for part A, if I want to know the area, what shape is this? It's a rectangular prism. And if I use the formula, the area of the base multiplied by the height, this is what it would look like. The base is the bottom, or in this case, the same as the top. I'll highlight the top. How would I find the area of that rectangle? Length times width. 6 times 4 or 4 times 6. Does it matter? Does it matter which one you call the length? Like, do I get a different answer if I go 4 times 6? If I go 6 times 4? No, they're both 24. But here's what I do. I'd go 6 times 4, and then I'd multiply that by what? What's the height of this prism? 10. And I end up with 24 times 10. What's 24 times 10? 240. And remember, when you're doing area, that you're going to have to write units squared. Now, some people ask, is it okay if I just go A equals length times width times height, 4 times 6 times 10, or it doesn't matter if they go 10 times 6 times 4? Sure, that's still going to give you 240 units squared. I'm just showing you that for prisms, you can always use this general formula. So for part B, I'll do the same thing. It's the area of the base. What shape is the base, though, for this next triangular prism? It's a triangle. That's right. The base of the triangle. How do you find the area of that red triangle? Anyone know? What's the area of a triangle? 1/2 the base times the height, or some people think of it as base times height over 2, same thing. Fair? So what would I write in the red brackets? 6 times 4 divided by 2, and then I'd multiply all of that by how much? 10. Now, if you want to solve this separately, what is 6 times 4, guys? 24 divided by 2? 12. And I end up with 12 times 10. I don't have to show this step. What's 12 times 10? It's 120. And what would I write after it? Units squared. Now I'm writing units because I don't know if it's centimeters. I heard someone say centimeters squared. I don't know if it's meters or inches or feet. It says here the dimensions are, and I stand corrected. So what should I be writing here? Good eye. Thank you very much. These are centimeters squared. Cubed. My bad. Another glitch. We're not finding area. What are we finding? Good catch. We're finding volume. So could you change all of those A's to V's? And could you change all of your centimeters squared to centimeters what? Centimeters cubed. And the reason it's centimeters cubed, I apologize, it's because it's 6 centimeters times 4 centimeters divided by 2. That'd give me centimeters squared. Then I'd multiply it by 10 more centimeters. That gives me centimeters to the power of 3. Volume is always in cubic units. Area is always in square units. These are volumes. Yep. So make those corrections. My apologies. Part C. The volume is going to, once again, equal the area of the base multiplied by the height. What shape is the base here? It's a circle. What's the area of a circle? It's pi times the radius squared. That's right. So in these brackets, I'll write pi. What's the radius? It's 3 squared. That's the radius. And then I'll multiply it by the height, which is 10. So without a calculator, this is what we'd have. What's 3 times 3? That's not 3 times 2. It's 3 squared. 9. I'm going to end up with 9 pi times 10. 9 pi times 10 would give me 90 pi, and I'd write centimeters to the power of 3. That's what it is as an exact value. That's great. As an approximate value, I'd have to take my calculator, and I'd go 90 times pi. And I'll use the pi button on my calculator, not the 3.14. So the pi button is 3.141592654. When I multiply that by 90, I get 282.7433 cubic centimeters. And we'll go to 4 decimal places. That's an approximate value. Fair? So those are for prisms. In general, it's just the area of the base times the height to find the volume. And again, volume is in cubic units, or units cubed to the power of 3. All right. The next slide talks about a sphere. If you are given a sphere and you are asked to calculate its volume, you just take 4 and multiply it by pi and multiply it by the radius to the power of 3. And then you divide by 3. Okay? The next slide talks about cones in pyramids. Okay? The volume of a cone, and you can write this on your page. It looks like this. It's 1/3. The area of the base would be pi r squared. That's for a cone. Because the base of a cone is a circle. Now, if you wanted to write this as one nice formula, you could call it pi r squared h divided by 3. For a pyramid, it's 1/3 times the area of the base. Well, the area of a base of a pyramid can be a rectangle, so it could be length times width. Multiplied by the height. And if I do this, I end up with 1 times L times W times H. It's LWH over 3. Length times width times height divided by 3. Now that's for a rectangular pyramid. For a triangular pyramid, this would change from length times width to length times width divided by 2, because that's the, and then you'd end up with length times width times height divided by 6. Okay? We'll tackle those ones as we come to them. Fair? Next example, I think we have a cone and a pyramid. There's 2 more left. And it asks for the volume. So remember, the pyramid and the cone, the ones that come to a point, those are the ones that you divide by 3 or multiply by a third. Wants the volume. What shape is this? It's a pyramid. It's a rectangular pyramid. And the volume of a rectangular pyramid, it's the area of the base. What's the base in this case? It's a rectangle. So what would the area of that be? 8 times 6. Do I got to divide by 2? No, it's a rectangle. It's not a triangle. Then I have to multiply that by the height. What's the height of this pyramid? It's 12. And then I have to remember to divide by what? For a pyramid or a cone, if it comes to a point, what did we say we were dividing by? 3. And if I do 8 times 6, that's 48, times 12, that's 480, and 96, 576, divided by 3. I get 192, and I'll put units cubed this time because it doesn't say that these are measured in centimeters. So it's just the area of the base times the height divided by 3. And in this case, the base was a rectangle. That's why I went 8 times 6. Last question. Looking at a drumstick, a super drumstick. That's a tasty little treat. Okay. The 13 represents the height. So this is the H. The 4 represents the radius. Remember, for the volume of a, what shape is this? It's a cone. The volume of a cone is the area of the base. If I flip this upside down, the base is a circle. And the area of a circle is pi times the radius squared. That gets multiplied by the height, and I would have to divide that by 3. What am I going to fill in for the R value? Anyone? I'll fill in a 4. So I'm going to put pi, and this would become 4 squared. Multiply that by the height, which is 13. And I divide that by 3. As an exact value, this is what I would write. What's 4 squared? 16, nice, times 13. That gives me 208 pi over 3. So 4 squared is 16 times 13 is 208 times pi is 208 pi over 3. Now I will do the following. I'll do 208 multiplied by, I'll hit the pi button. So multiply by 3.141592654. And then I'll divide that in, so that gives me 653 and change. I'll divide that by 3. And I get 217. This is an approximate value. And I'll go 0.8171, 4 decimal places. And I'll put units cubed. Is that all right? And that's where we'll break. And you can start the review or the homework sheet.